All right, so this is actually 3.6a, f prime, f double prime. So I'm going to label it slightly different. But let's just chat. So if I have f and I find if I have a 0 of f, that's actually solving for an x-intercept or a 0 or a root. All right. When f is positive, that means it's above. And if f is negative, that means it's below the x-axis. Yes? Mm-hmm. However, when we talk about f prime, and I set that equal to 0, that's actually doing a what? That's finding what? Critical numbers. And what happens at critical numbers? Relatives happen at critical numbers. And what f prime being positive means is that f is increasing, and negative is that means f is decreasing. However, when we set f double prime equal to 0, what do we actually find? Possible points of inflection. However, to get a point of inflection, what do we need to have happen? F double prime changes sign. It's a change in concavity. And so F double prime is actually about concavity, which is really the slope of F prime. All right, and so that's really what's happening. Now, this is actually a cool little technique of a little circle. However, we usually use our hands. So when I say F double prime is less than 0, we use our hands. And then it's like, hey, F prime is greater than 0. It's going up, so forth like that. All right.
If the graph above the graph of a function f of x on the interval -7 to 7, on what open intervals is the f of x both decreasing and concave down?
All right, beautiful. So f of x is going to be our graph right now. That's what we're going to call it. And it says f is decreasing. So what does that mean?
Going down.
It's going down. And what does it mean to be concave down? Looks like that. And so when is f decreasing and concave down?
2 to 3.
Okay, from 2 to 3. There is another interval.
-7 to 5.
-7 to 5. -5, sorry. All right. And so then it doesn't say justify it, but it's because it's going down and it looks like that's concavity. All right. So let's keep going. Number 2.
On what open intervals does f of x, on what open intervals is f of x both increasing and concave down?
All right. So now increasing means what? It's going up. And concave down means looks like that. And so where is it both increasing and concave down? -1 to 2. All right. Number 3.
At what x values does f of x have an inflection point?
All right. What makes an inflection point? Change in concavity. And so where do we have inflection points? We got a decent amount of them here. X equals -5. Where else? -1. Where else? 3. Anywhere else? No. All right, and so those are our points of inflection for our x values. All right, now let's look at B. So now we're going to change the way we are thinking, and Luke is going to be our reader for part B.
If the graph above is the graph of a function f prime of x on the intervals -7 to 7, on what open intervals is f of x increasing?
All right, so a lot of these times I like to justify first, but we have an f prime graph now. It's not an f graph anymore, it's an f prime graph. And so now f is increasing. What does that mean? We just want what? F prime to be what? Greater than 0. And this is an f prime graph, so when is f prime greater than 0? From what? -7 to? -5. When else? -1 to?
It's going to be greater than or can be equal to?
It's not equal to. -5 to, or -1 to, 5, and 5 to 7. Go ahead, Luke.
At what x values does f of x have a local minimum? Justify.
All right, so a local minimum now. I like to do my justifications first. What's going to make a local minimum? When f prime does what? When f prime changes from negative to positive. All right, so a lot of the times I like to work backwards on these. So when does f prime change from negative to positive? At x equals what? At x equals -1. Because f prime is changing from negative to positive right there. All right, let's look at number 3 now.
On what open intervals is f of x concave up?
All right, so f of x being concave up. Well, what's given to me? It's an f prime graph. So how do I get from f prime to f double prime? I actually need to talk about the what of it? The slopes of these graphs. All right. And so what I want to do is I want to find out when the slopes of what? F prime are what? Are positive. That's really what I'm looking for. I'm really finding the slope of F prime being positive. That means I'm going to be concave up on F. And so where is my slope of F prime positive? From negative 3 to 2. And when?
5 to 7.
And from 5 to 7. So F is concave up when F prime slope is positive.
At what x values does f of x have an inflection point? Justin.
All right, so what makes an inflection point? Again, I like to do my justifications first. A change in concavity, but how do I say that?
Oh, when F.
Okay, I don't have an F double prime though. So how do we say the F double prime when we don't even have an F double prime? It's the slope of F prime. So I need the slope of F prime to do what?
Change from negative to positive or positive to negative.
Exactly. So I need the slope of F prime to change sign. I'm not sure why I have 2. The slope of F prime changes sign. All right. And so when is the slope of F prime going to change signs? At x equals what? Negative 5. No. Negative 3. When else?
2.
2. And when else?
5.
And at 5.
If the graph above is a graph of the function f double prime of x on the interval of negative 7 to 7, on what open intervals is f of x both concave down?
All right, I shouldn't say both. F of x concave down. All right, and so this is now a what kind of graph? An F double prime of graph. All right, and so when is F concave down? When F double prime is what? Negative. When F double prime is less than 0. And so when is F double prime less than 0? Negative 5 to negative 1. So that is when F is concave down, because F double prime is less than 0. All right, let's look at number 2.
What x values does f of x have an inflection point?
All right, so how do we get an inflection point?
Change in concavity?
A change in concavity. But I'm given F double prime, so let's talk about it. So because what? What's F double prime going to do? It's going to change sign. So when does F double prime change sign? At x equals what? At negative 5. When else? Negative 1. Anywhere else? No, nowhere else. What is actually 5? It's when F double prime is equal to 0, but that is not a point of inflection. That's actually a what? A possible, a poi. That's a possible point of inflection. However, it did not change sign for F double prime. All right.